Section 800 of the National Electrical Code addresses the requirements for installing telephone cables. Specifically, Section 800.40 requires that telephone cables be installed in raceways unless otherwise permitted by the National Electrical Code. This means that, in general, telephone cables must be enclosed within a conduit or other approved raceway system to provide physical protection and to prevent the spread of fire. There are exceptions to this rule, which are detailed within Section 800 of the National Electrical Code. These exceptions typically involve situations where the cable is run in a concealed space, such as within a wall or above a suspended ceiling, or where the cable is specifically listed for exposed use. However, it's crucial to always refer to the latest edition of the National Electrical Code and consult with a qualified electrical inspector to ensure that your installation complies with all applicable requirements. A raceway is defined as an enclosed channel designed expressly for holding wires, cables, or busbars, with additional functions as permitted in the code. Raceways can be made of metal or insulating material, and the term includes rigid metal conduit, intermediate metal conduit, electrical metallic tubing, rigid non-metallic conduit, electrical non-metallic tubing, underfloor raceways, cellular floor raceways, surface raceways, wireways, and busways. The primary purpose of using raceways for telephone cables and other types of wiring is to provide mechanical protection. This protection safeguards the cables from physical damage, such as abrasion, impact, or crushing, which can occur during and after installation. Mechanical protection also helps prevent accidental contact with energized conductors, reducing the risk of electrical shock. Secondly, raceways offer fire protection. By encasing cables in a fire-resistant raceway, the spread of fire can be slowed or contained. This is particularly important in commercial buildings and other structures where fire safety is a major concern. Certain types of raceways, such as metal conduits, can also act as a heat sink, dissipating heat generated by the cables. Thirdly, raceways provide a pathway for future expansion or modifications. By installing a raceway system, it becomes easier to add or replace cables without having to tear into walls or ceilings. This can save time and money in the long run. Finally, raceways can provide a degree of electromagnetic interference (EMI) shielding. Metal raceways can help to block electromagnetic radiation, preventing it from interfering with sensitive electronic equipment. This is particularly important in environments where there is a lot of electrical noise, such as hospitals or industrial facilities. When installing telephone cables in raceways, it's important to follow certain guidelines to ensure a safe and compliant installation. Firstly, you should select the appropriate type of raceway for the application. Consider factors such as the environment, the type of cable being installed, and the level of protection required. Secondly, ensure that the raceway is properly sized to accommodate the cables. The National Electrical Code specifies the maximum number of cables that can be installed in a given size of raceway. Overfilling a raceway can lead to overheating and damage to the cables. Thirdly, use the correct fittings and connectors. The fittings and connectors should be compatible with the type of raceway being used and should provide a secure and watertight connection. Fourthly, support the raceway properly. The raceway should be supported at regular intervals to prevent sagging or damage. The National Electrical Code specifies the maximum spacing between supports. Fifthly, avoid sharp bends in the raceway. Sharp bends can damage the cables and make it difficult to pull them through the raceway. The National Electrical Code specifies the minimum bending radius for raceways. Sixthly, ground the raceway properly. Metal raceways should be grounded to provide a path for fault current. This helps to protect against electrical shock. Finally, inspect the installation after it is complete. Make sure that all connections are tight and that the raceway is properly supported. Verify that the installation complies with all applicable requirements of the National Electrical Code. Section 800 of the National Electrical Code provides specific requirements for the installation of communications circuits, including telephone cables. These requirements are intended to ensure the safety of people and property and to prevent interference with other electrical systems. The scope of Section 800 covers communication wiring and equipment. This includes telephone, telegraph, outside wiring for fire alarm and burglar alarm circuits, and similar systems. It does not cover radio and television receiving equipment or community antenna television systems, which are covered in Section 820 of the National Electrical Code, or low-voltage power circuit cables, which are covered in Chapter 7. Section 800 addresses several key aspects of communication cable installations. Firstly, it covers general requirements. These requirements apply to all communication cable installations and address issues such as the type of cable to be used, the methods of installation, and the protection of the cable from physical damage. Secondly, it covers cable marking. Communication cables must be marked to identify their type and voltage rating. This helps to ensure that the correct cable is used for the application and that it is installed properly. Thirdly, it covers grounding. Communication cables must be grounded to protect against electrical shock and to prevent interference with other electrical systems. The grounding requirements vary depending on the type of cable and the location of the installation. Fourthly, it covers separation from other conductors. Communication cables must be separated from power conductors to prevent interference and to reduce the risk of electrical shock. The separation requirements vary depending on the voltage of the power conductors and the type of communication cable. Fifthly, it covers installation of communication wires, cables, and equipment. These requirements address issues such as the support of cables, the protection of cables from physical damage, and the routing of cables through buildings. Section 800.40 specifically addresses wiring methods. This section specifies the approved methods for installing communication cables, including the use of raceways, cable trays, and other wiring methods. Section 800.40 requires that communication wires and cables installed exposed on the surface of ceilings and sidewalls shall be supported by the building structure in such a manner that the cable will not be damaged by normal building use. This means that the cables must be securely fastened to the building structure and that they must be protected from physical damage. Section 800.40b requires that communication wires and cables installed in raceways shall comply with the requirements of Chapter 3 of the National Electrical Code. This means that the raceways must be properly sized, installed, and supported, and that the cables must be properly pulled through the raceways. Section 800.40c covers other wiring methods. This section allows the use of other wiring methods for communication cables, such as cable trays and open wiring on insulators, provided that the wiring methods are approved for the application and that they comply with all applicable requirements of the National Electrical Code. In addition to Section 800.40, other sections of Section 800 address specific aspects of communication cable installations. Section 800.44 covers overhead communications wires and cables. This section specifies the requirements for installing communication cables overhead, including the clearance from buildings, the strength of the cables, and the grounding of the cables. Section 800.47 covers underground communications wires and cables entering buildings. This section specifies the requirements for installing communication cables underground, including the depth of burial, the protection of the cables from physical damage, and the grounding of the cables. Section 800.50 covers grounding methods. This section specifies the methods for grounding communication cables, including the use of grounding electrodes, grounding conductors, and bonding jumpers. The grounding requirements vary depending on the type of cable and the location of the installation. It is important to note that the National Electrical Code is a complex document and that it is constantly being updated. It is essential to consult the latest edition of the National Electrical Code and to consult with a qualified electrical inspector to ensure that your communication cable installation complies with all applicable requirements. In general, compliance with Section 800.40 mandates the use of raceways for telephone cable installations unless specific exceptions are met as outlined in the National Electrical Code. Understanding these requirements is critical for electrical contractors, installers, and anyone involved in communication systems to ensure safety, code compliance, and long-term reliability of the installation. Always refer to the latest edition of the National Electrical Code for the most up-to-date regulations and consult with local authorities having jurisdiction for any specific local requirements. For example, Section 300.4 covers protection against physical damage. Specifically, 300.4d addresses protection from physical damage for cables and raceways through metal framing members. In both exposed and concealed locations, when non-metallic sheathed cables or electrical non-metallic tubing pass through metal studs, joists, or rafters, they must be protected by bushings or sleeves. These must be designed and installed to protect the cable from the sharp edges of the metal framing members. Where holes are cut or punched in metal framing members, the holes must be sized so that the cable or raceway is not subject to abrasion. Where the opening is oversized, a listed bushing or grommet must be installed in the opening prior to the installation of the cable or raceway. Similarly, 300.4f covers cables and raceways installed in shallow grooves. Where cables or raceways are installed in shallow grooves of wood, plaster, or similar materials, they must be protected against physical damage by steel plates or sleeves at least 1.59 mm or 1/16 of an inch thick. The plates or sleeves must cover the area of the wiring and must be attached so as to protect the cable or raceway from nails, screws, or other fasteners. Regarding the ampacity of conductors, which relates to the current carrying capacity of a wire, you must consult tables such as Table 310.16, which provides ampacity ratings for various conductor types based on their insulation and installation conditions. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specific conditions of use without exceeding its temperature rating. Table 310.16 provides ampacity ratings for conductors based on insulation type, such as THHN, THW, and others, and also considers the ambient temperature and the number of current-carrying conductors in a raceway or cable. When conductors are installed in a raceway or cable with multiple current-carrying conductors, the ampacity must be derated to account for the increased heat generated by the conductors. The National Electrical Code provides adjustment factors for derating ampacity based on the number of conductors in a raceway or cable. For example, if there are 4 to 6 current-carrying conductors in a raceway, the ampacity must be derated to 80% of the value listed in Table 310.16. If there are 7 to 9 current-carrying conductors, the ampacity must be derated to 70%. These adjustment factors are essential to ensure that conductors do not overheat, which can lead to insulation breakdown, fire hazards, and equipment failure. Ambient temperature also affects the ampacity of conductors. Table 310.16 is based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, the ampacity must be derated. The National Electrical Code provides correction factors for adjusting ampacity based on ambient temperature. For example, if the ambient temperature is 40 degrees Celsius, the ampacity of a THHN conductor must be multiplied by 0.91. These correction factors ensure that conductors are not operated above their temperature rating in high ambient temperatures. The size of the overcurrent protection device, such as a circuit breaker or fuse, must be selected to protect the conductors from overcurrent. The overcurrent protection device should be sized no larger than the ampacity of the conductor it protects. However, there are exceptions to this rule for specific types of equipment and installations. The National Electrical Code provides guidance on selecting the appropriate overcurrent protection device for various applications. Voltage drop is also a critical consideration in electrical installations. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or fail. The National Electrical Code recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. To minimize voltage drop, conductors should be sized appropriately for the length of the circuit and the amount of current being carried. Using larger conductors reduces the resistance of the circuit and minimizes voltage drop. The National Electrical Code provides guidance on calculating voltage drop and selecting the appropriate conductor size. Regarding grounding and bonding, These are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and energize the circuit. Bonding connects whole metal parts of the electrical system together to create a low impedance path for fault current. The National Electrical Code requires that all metal enclosures, raceways, and equipment be grounded and bonded. Grounding electrodes, such as ground rods or ground plates, must be installed to provide a connection to earth. The grounding electrode conductor connects the grounding electrode to the electrical system. Bonding jumpers are used to connect different metal parts of the electrical system together. Proper grounding and bonding are essential to protect against electrical shock and to prevent equipment damage. Finally, labeling and identification are important for maintaining a safe and organized electrical system. The National Electrical Code requires that all circuits and equipment be labeled with their purpose and voltage. This helps to prevent accidental contact with energized conductors and to facilitate troubleshooting. Labels should be durable and easily readable. Panel schedules should be provided to identify the circuits in each electrical panel. These schedules should be accurate and up to date.